Hello everyone, welcome to part 2 of topic 8 about game theory. We saw in the previous part the introduction to game theory, and also we show some examples and the game modeling, and also we mentioned about this extensive forum games and by matrix. We saw how to treat this by matrix games. In this part, we introduce in some mathematical form about the game payoff of two players. So you can see here that, for example, this is the utility or the payoff of player X, and then it is function X and Y. X here is vector. So X means that it can be, for example, a vector of the strategies of player X. Okay, so player X might have n strategy that they can play with in different strategies, and player Y might have m different strategies. Okay, in case of discrete, or it can be also continuous. It can be continuous. Okay, so now this is the payoff of player X, and this is payoff of player Y. Okay. In case of discrete strategies, we can represent the previous one as X A Y transpose. I will explain it in more details soon. And also for player Y is X B Y transpose. What does that mean? Okay, let me have a note here to explain this. So assume that we have this game. It is between two players. Okay, and assume that every player has two strategies. Strategy 1, we can say x1 and x2, and player Y has y1 and y2. Okay, now assume that if player 1 plays with x1 and player 2 plays with y1, then the player 1 will get 5 and player 2 will get 1. And this case that if player 1 plays strategy x1 and player 2 play with the strategy y2, then player 1 will get -1. It is not zero matrix now. So, and player 2 gets, for example, 3. Just numbers that I put here. And here it is maybe 2 and 7 and 5 and -6, for example. Okay, now the matrix of, or the payoff matrix of player X can be represented as A equal to, as you can see, it is 1, -1, 5 -1, and 2, 5. And for the player Y, or player 2, is 1, 3, 7, -6. Okay, now how could we play now this game? So, or what is the utility? So the utility of the of user X, or of player 1, is equal to A. It is the first that we have X. Okay, so it can be, for example, x1, x2, okay, times the matrix A, so it will be times 5 -1 to 5, and then times Y transpose, which is y1, y2. I will explain this, what that means. So now this vector is 1 row times 2 column. This one is 2 by 2. This one is 2 by 1. So the result will be 1 by 1. It will be scalar. Okay. Now if you multiply, because now x1 and x2, actually, that player 1 should play either x1 or x2. It is discrete case. Now we assume that we play pure strategy. So that x1, if x1 is 1, then x2 is 0. It means that player 1 play with x1. If x2 is 1 and x1 is 0, then it means that player 1 plays with the second strategy. Okay. This could be represented as ux equal to, it will be, of course, this times this one. It will be like x1 times 5 x1 plus 2x2, and the second element will be minus x1 plus 5x2, and then this multiplied by y1 and y2. So this will have ux, the utility of x will be the first element times y, so it will be 5x1 y1 plus 2x2 y1, and then this y2 times minus x1, so it becomes minus x1 y2 plus 5x2 y2. Actually, this is the utility function of the player 1. So player 1, if player 1 plays with strategy 1, it means that x1 equal to 1, and this means also that x2 equal to 0. And if player 2 plays with the second strategy, it means that it is y1 equal to 0 and y2 equal to 1. So you can substitute them here. So what you will get that ux equal to this 1 and y1 is 0, so this will be 0. The only one that you will have when that x1 equal to 1 and y2 equal to 0. So when you have x1 and y2, so x1 and y2 is here, that both they are 1, then ux equal to minus 1. Let us go back. So this is now if player 1 play with first strategy and the player 2 plays with the second strategy, then the player 1 will get minus 1. So this is just mathematical representation. This is just a mathematical representation how to represent the utility of ux and utility of uy. Okay. So this is we put them in this form. So we have x times a times y transpose. Remember that here x is row vector, y transpose, y is itself is row vector, so y transpose will be column vector, so the result will be a scalar. So this will be for ux and for uy. Okay, so if we play with pure strategy, it means that we have that x and y should be either 0 or 1. Okay, and only one row will be 1 and the others are 0. This is in the pure strategy. But it is also possible that we play the game in randomized strategy. In a randomized strategy, it means that you can play each strategy with certain probability. In this case, the expected value that we will have, it will be, or the payoff will be the expected value of the payoff. It will be the expected value. It will not be deterministic anymore, but it will be probabilistic. However, that when you play it as it is shown here, if you play it with the probability, it means that the summation of the probabilities must be 1, because now you will have, for example, in this game, okay, assume that player 2 has 3 strategies. It is y1, y2, and y3, and player 1 has only 2 strategies, x1 and x2. Then they will play that the strategy 1 with the probability. So it will be like probability of x1 plus probability of x2 must be 1. So the total probability must be 1 because they will play one of them. And also the sum of these probabilities, probability of y1 plus probability of y2 plus probability of y3, also equal to 1. So this is called like mixed strategies, or that you play with an randomized strategy, and we will explain this later. Okay? Yes. Here we have few examples about those, for example, for these 2 cards that we explained in part 1, that we can represent them here, as you can read from the slides, that for example 1. So we have player 1, the optimum for player 1 is to play always with red, and the optimum for player 2 is to play always with black, and this will be the result. So ux and uy will be both of them 0. And this is the payoff of example 2 of the case of the 2 places with 2 cards. It is 4 card game that we explained before. Okay, now let us talk a little bit about the zero-sum games analysis. In the zero-sum game, actually, we have what is known as lower value of the game and the upper value of the game. the lower value of the game is the maximum of the minimum of the selections. Let me explain this with an example, so it will be much easier to understand this. So now if we assume that that you have let's say two players, and the player 1 has two strategies, for example x1 and x2, and assume that player 2 has four strategies, that y1, y2, and y3, and y4. Now we are talking about zero-sum game. Zero-sum game, it means that the number you put here will be the payoff of player 1. Will be the payoff of player 1. And the player 2 will be just the inverse. For example, if we assume this is -1, -5, 2, 5, for example, what does that mean? When you put here -1, it means that the player 1 will get -1 and player 2 will get 1. This is -5, it means that player 1 will be -5, player 2 will be 5. It is zero-sum game, okay? And assume here that we have 2 and 3 and maybe -1, and let's say this is 7, okay? Now, assuming that we start with player 1. So player 1, if player 1 play the first row, okay? If player 1 plays the first row, player 2, which column they should play? This simple question. If player 1 play with first row, strategy of the first row, what column that player 2 should play? Of course, player 2 should select the column which minimize the payoff of player 1, because minimizing the payoff of player 1 means maximizing the payoff of player 2. Player 2 looking for their own interest, so they will look to minimize the payoff of player 1. So now look to this row, -1, -5, 2, 5. Of course, player 2 will select this one. So here will play -5. So this will be the minimum. This will be the minimum of the row. Okay, this is the minimum of the row. Now, if player 2 plays with second row, okay, which one player 2 will play? 2 or 3 or -1 or 7? Of course, they should play this one, because this will minimize for player 2, which for player 1, which means that maximizing for player 2. So this will be -1. Okay, now we have here -5 and -1. The maximum of these values, will be -1. Now, this -1 is called the minimum or the floor of this game. So the floor of this game is -1. So the floor of this game is the maximum of the minimum. Is the maximum of the minimum. Okay? So because now if this is -1, -5, and -1 for each row, which one that player 2 will select? Player 1 will select. Of course, player 1 will select this one. Will select this one. So this one actually the minimum that player 1 guarantee to receive, or of course, or the maximum to lose. The maximum to lose or the minimum to receive. This is for player 1. Okay, so this is the ground or the floor of this game. Okay, what is the upper bound of this game? Okay, now let us go from different point of view. Now, if player 2 plays the first column, -1 and 2, what do you think? Which row that player 1 should play? Of course, they should play with the row which guarantee the maximum. So here the maximum is 2. Okay, and okay, now player 2 plays the second strategy. Which row that player 1 should play? Of course, they will play the 3. If player 2 plays the third one, the player 2 player 1 will play, of course, the first, because it will be the maximum, because they are looking to maximize. And if player 2 plays the fourth one, 5 and 7, then of course player 1 will play for the 7, so this will be the 7. Okay, now what is the minimum of this? If we have 2, 3, 2, 7, what is the minimum? Because the minimum is the one where player 2 will select. Of course, we have two minima here, 2 and 2. If we take this one, then it will be 2. So v plus equal to 2. So v plus is the maximum of the minimum, is the maximum of the minimum. So actually v plus is the maximum that player 2 may lose. Okay, and this is very important to remember. So this is the maximum player 2 that it may lose is v plus, and v minus is the maximum that player 1 may lose. Okay, so you can see that the game always is between these two values, v plus, and v plus is always greater than or equal to v minus. In case that v plus equal to v minus, then we have like saddle point in pure strategies. Okay, so this was explained here. So the lower value of the game is the maximum over all like rows of the minimum of all columns. Okay, as we explain it now by this example. Okay, and v plus is called the upper value of the game. V plus is the upper value of the game. So player 2 will therefore choose for the column J which minimize the pay of the player. So this is actually that actually player 1 to guarantee a loss of no more than v plus. So this is the loss, the maximum loss of a player. V plus is the maximum loss of a player 2. Maximum loss of player 2, and v minus, as I explained before, is to guarantee that the worst possible situation that what they will get, the minimum that they will get, or of course the maximum that they can lose. Okay, so v minus is always less than or equal to v plus. So how to compute them, as I explained now. So you look to the first row, and then you select the minimum, and select the minimum of the second row and up to the minimum of the nth row. Then you take the largest value. The minimum are selected by the player 2, and the maximum here is selected by the player 1, and the reverse is obtained here. So every player, now we player 1 will select also always the maximum of each column, and then player 2 will select the smallest one. Then each game actually between the v minus and v plus. We have this simple example now we can see. So if we look to this player 1, they can play 3 strategies, and the player 2 they can also play 3 strategies. And now for each row, that if player 1 plays A, then the player 2 for sure they will play C, because this will minimize what is for A, and also it means that it is the maximum utility that player 2 can obtain. And now with B we have these numbers. Then which one they should select? Of course they must select A, because this gives the minimum. Player 2 always minimizing, player 1 always maximizing, because it is zero-sum game. Okay, now if they play C, then the minimum here is 0.28. So the maximum out of these 3, why we select the maximum? Because now it is the turn of player 1 to select out of these 3. So for sure that they will select the maximum. It will be the lower bound of the game, or the lower value of this game. And also for the player 1, if the player 2 selected A, then player 1 will play 0.3, because they will maximize, and this is the maximize value, and this is also maximizing, and the minimum is 0.3. So this is the v plus. Okay, so now if I said as I said that when v minus equal to v plus, then we have what is known as saddle point, or the equilibrium of this game. Okay, so the game of 2 players that what we explained now, the randomized strategies that I mentioned here, that we can also play with some randomized strategy that instead of deterministic one. So one example for this simple, the simplest possible example, assume that you play with another player, that everyone they should show like 1 or 2 or 3 fingers at one time, but it will be simultaneously in the same time. So if the summation is odd, then you lose, and if the summation of the number of fingers that is even, then you win and the other lose. So in this case, actually, if your opponent, they know that what you are biased, for example, to show 2 fingers, then they will show always like 1 finger, because in this case that the summation will be odd and you will lose. And because of that, you need all the time that to show just a random number. So you need to show random number. So there are some games that the player should play with some like randomized strategy. So they don't play with the same strategy, but with randomized strategy. But even in the case of randomized strategy, we have some strategy to achieve what is the optimum probability for each one to play. Of course, it is one lecture about game theory, so we don't have time to cover all this in details, but this is just the concept of this probability. And in the case of a probability, that we have expected payoff, not deterministic payoff, but we have the expected payoff. Now we come to the crucial point of game theory, which is the most important part of the game theory, is the definition of the equilibrium point. The definition of the equilibrium point, that what is the best strategy that every player should play. We call this best strategy as Nash equilibrium. So it is equilibrium point. Okay, the equilibrium point is defined like that. If we assume that the equilibrium point of player X is X star and for player Y is Y star. So the payoff of player X, if both of them they play with this star, with the equilibrium point, will be always greater than or equal to if player 1 decide to play any other strategy than the equilibrium point 1. So if they play with X, any X, not the equilibrium 1, and the other player play with the Nash equilibrium strategy, then they UX will be always less than this one. So what it means? It means that player 1 cannot do better if they deviate from the best strategy or the equilibrium strategy. And it will be the same for player Y. So for player Y, if they deviate, if they play any other strategy than Y star, they will lose. Okay, so in general, that the equilibrium point, or it is called the Nash equilibrium point, or it is not necessary, by the way, to be optimum in general, but the equilibrium solution for any game that is that one where any player deviate or decide not to play with this optimum one, the other player can get benefit of that, and they can do better than by deviating the first player. So there is no choice in order to get this equilibrium point that both players play with it. Anyone deviate, he or she will lose. Okay. So this is the definition of the Nash equilibrium, that no player could do better by deviating from the Nash equilibrium solution if the other player played it. Okay, if the other player played the Nash equilibrium, then the player who deviated from it, he or she will not be able to do any better. So in terms of the payoff. So usually, actually by deviating, the other player can get benefit of that, and they can get even higher payoff than before. Okay, however, the Nash equilibrium solution is not necessarily the optimum one. Moreover, it is not necessarily a good solution for all players, by the way. Actually, I'm going to explain this in more details in different examples. Now we just give these concepts now here. Okay, so in general, the Nash equilibrium point is the best expected payoff that both players can obtain, given that both players play the saddle point or the Nash equilibrium point. So this is actually very important to remember. Okay. However, if one of them deviates from the equilibrium strategy, then the other player may increase her gain to be higher than the Nash equilibrium by playing with the best response strategy, as will be as discussed or as we will see also in some examples. Some interesting examples are coming. Okay. Actually, we can explain this in more details with this very interesting and very well known as well. Is called as prisoner's dilemma. So we are going to explain this the Nash equilibrium, that, and we will show that the Nash equilibrium that no one can do better by deviating from it, and we will show also that it is not necessary that to be the optimum solution for all the players. Okay, let us go about this example, but this will be for the next and the last part of this topic. Thank you.